So welcome everyone to this talk. My name is Gabor Szarnyas, and I will talk about DuckDB and duckplyr today. So my background is that I'm a database systems guy. I did most of my studies on NoSQL systems and graph databases and continued through PhD to postdoc. But I was always a heavy R user when it came to plotting. So if you open any of my papers, you will see these very typical GG plots there. Ultimately, my academic career took a turn into relational database world, and I ended up at DuckDB Labs. And at DuckDB Labs, I do developer relations, I edit the blog, I write the documentation, and talk at events like this. So DuckDB in one slide can be put here, which is a spectrum of data processing systems. If you think about the amount of data that you have to produce, for a few megabytes, Excel is great. For a few gigabytes, you can use data frame libraries like dplyr. And if you have really lots of data, a terabyte or more, feel free to run your own Spark cluster or use one of the cloud data warehouses. But this in-between space, which is actually quite large, between 10 to 1 terabyte, wasn't really well served until DuckDB was created. And I think DuckDB has this really sweet spot position in this area. And in this talk, I will explain why DuckDB works, why it can be created now, and why it wasn't possible 10 years ago, and why it works well with R. So the answer to the question of why it wasn't possible 10 years ago is because 10 years ago, laptops were pretty slow, and DuckDB is really something that's designed for modern end-user devices. Most of us have fast MacBooks or one of these new Windows laptops, which have 10, 12, 14 cores, and 16, 32, or even more gigabytes of memory. DuckDB makes really good use of the modern hardware by running parallel queries, using the fast disks in these laptops, and making use of the available memory. Here's a small demo that I made. The demo is created in Positron, and it uses the Dutch railway service dataset. And this is a very well-behaved CSV file. If we look into this, we see that it has some service ID, some date, and lots of information on how a particular piece of railway service was served. Was it delayed, or did it reach the station in time? So I will just make some space so that you can see the code. And what you can see is that this notebook starts with a few imports. And then I have this single line that says create table services that loads the railway services in the Netherlands for the last 5 years. And this is a table of roughly 100 million rows. And DuckDB loads this in about 15 seconds. So 103 million rows, and the loading has just finished. And now that we have it loaded in DuckDB's in-memory representation, we can run queries on it. For example, we can say, well, people always complain about the railway. How much did the railway services delayed? How much delay did they accumulate in every year on average? And we can run a query, and we can see that it's very snappy. It runs in 100 milliseconds, and it's actually kind of a damning picture of the Dutch National Railway since 2020, where the railway was really easy to operate because there were no passengers. Every year, it has gotten worse and worse. And of course, this is not something you would want to present to a board of a company. You would want to visualize it. And luckily, DuckDB accommodates that really well in R. Delays is already an R data frame, and we can just pass it to ggplot. And we can, after some fiddling, return this plot. So this is a very nice, visual, concise answer to, did the railway get worse over the years? The answer is yes, and we could produce it from looking at the CSV first to actually having this plot in just a few minutes. So if you go back to the demo, this leads me to the agenda for today, which is that I will explain how DuckDB works, how it's architected, what integrations it has with R, and what integrations it has with other systems. So DuckDB is a database system, and the database system is something that we are used to run somewhere on a big iron machine. This big iron can be on the cloud, it can be on premises, but it's something that we connect to via some transfer protocol. DuckDB takes this idea and flips it on its head by putting the database system into the client application. This eliminates a lot of the deployment complexity and makes DuckDB sit right where the data is. And DuckDB's own data, while DuckDB can run in memory, it can also be persisted into disk. It has a single database format like SQLite, and that single database file can be just stored on disk, and DuckDB puts all the tables, schemas, and everything there. And how does that DuckDB storage look like? It is rather important because it has a lot of implications on how you would use DuckDB. So traditional relational database systems like MySQL, Postgres, and other transactional systems, they use something called a row-based storage. In row-based storage, you have rows that belong together according to a single row in the table are stored together on disk. This is great if you want to insert one item or delete one item, but for analytics, it's better to have a columnar storage where the data is stored per column. And in the railway dataset, we can take something like this. We have railway services in May 24 and June 24 in these two row groups. And we have some information like IDs, stations, and delays. And what's really great about this is that you can compress this really well. The date is usually something that follows a sequential ordering. So it's ordered by time. The ID is also mostly sequential. And something like the delay is, in a good case, just a constant value. So you can compress these tables really well to 1/5 of what their size is in CSV format. If you have attended any database course, one of the things that they talk about a lot is indexing. And indexing is indeed really important in databases. However, what you typically learn is to define all sorts of tree-based and hash-based indexes, which is only applicable for transactional database management systems. For analytical systems like DuckDB, they do not work because they are a lot of overhead to maintain and create, and they don't really have the queries. We don't know the queries ahead. So what works really well for analytical systems is a lightweight indexing method. And DuckDB uses something called zone maps, which means that we only store the minimum and the maximum value for each column in each row group. So you can see here that we store the minimum date, the minimum ID, minimum station, and so on. This is very useful because some queries, like give me the delay on a given date on the 1st of June, can be answered just by looking at the metadata. You don't even have to touch the row group data on the disk. You can just touch the metadata that encodes the minimum and maximum indexes. And this also allows very efficient filtering. For example, if someone wants to query summer month, then they don't even have to go to row group 1. They just take the values in row group 2. And you can see that due to the columnar layout, one can ignore the ID, the station field, and only fetch roughly 1/4 of the data. DuckDB has an interesting philosophy for portability. We decided not to use anything other than plain C++11 code. This is an old version of C++, but it allows us to have a very portable system that can be compiled everywhere. If you have maintained R packages, a few years ago, CRAN even required Solaris builds, and DuckDB could build on Solaris. This obviously wouldn't be possible if you use some really exotic new programming language. But to have portability, we have to go one step further, which is we have to not use any external dependencies for DuckDB. So we took all the libraries that implement things like regular expressions, datetime functions, etc., and just inline them into the DuckDB code base. So we have a single C++11 file that is DuckDB. And this makes DuckDB very portable, and it can be used from different clients, and the databases that are created by these different clients are compatible. And the different clients are what you would imagine. We have Python, R, Jupyter, but also we have a command line client, Java, Rust, you name it. And we run all major platforms and on all architectures. What do we do in R? Well, in the demo, I have shown you that DuckDB can be used in R, and this is indeed our third most popular client application according to recent DuckDB user survey. And we have three major ways of using DuckDB in R. The first is the DBI API. So you can DB execute with queries with DuckDB. This works well, but it's a bit unwieldy to write those long SQL queries and pass them along as strings to DuckDB. One better is to load DuckDB and load dplyr. And what happens here is that you can use dplyr and you can formulate your queries with this fluent API that dplyr produces. But what ultimately happens is that DuckDB will generate a SQL query from this, and this will run that SQL query and give back the result. This is something that works, but it's rather a hack. So in the last few years, we have set out to create duckplyr, which is, again, DuckDB plus dplyr, but instead of creating a SQL string, generating the string and running it, we can simply directly run the dplyr syntax on DuckDB. And my demo has a bit shorter, simple illustration of this. If we import duckplyr, we can simply reformulate the query of calculating the average delay per year. And this is the traditional dplyr syntax, and including the CSV loading, this just happened in a simplified representation in 2.2 seconds, and we got a table back. So this, again, integrates really well with the R ecosystem. So we not only integrate with the R ecosystem, of course, but we also support a lot of other data sources. One of the main philosophies of DuckDB is that you should be able to get data in from lots of formats and get data out into lots of other formats and do this rather quickly. So on the file format side, we obviously support CSVs, Parquets, and JSONs. On the protocol side, we can read from HTTP endpoints, we can read AWS S3 buckets, we can read Microsoft Azure blob storage, and we can directly hook on into database systems like MySQL, Postgres, and SQLite. And on the client side, if you work in Python, we integrate with Pandas and NumPy, and in R, we integrate with dplyr. And these integrations don't really exist in isolation. Instead, they work together. For example, if you use your laptop and you want to query a Parquet file that's stored in the AWS S3 cloud, then these integrations work harmoniously to reduce your network traffic and your AWS bill at the end of the month. And the way they do this is that Parquet, the data format, actually has very similar ideas to the DuckDB database representation. It has row groups and it has min-max indexes. And whenever you issue a query, DuckDB makes good use of that metadata by selecting the columns that you want and seeking into the columns that you want, and also using the min-max index that's there. So if you run the query, give me the delays in the summer month, it will again take just the date column and the delay column from the second row group, effectively chopping the network traffic into 1/4 of what it would be. What's the state of DuckDB? DuckDB has been in development for more than 6 years, and we have released version 1.0 just a few months ago this summer. And interestingly, the system was, I would say, ready for release much earlier. But what took us so long is that we needed to achieve stable storage. We now have a storage that's backwards compatible. So if you create a DuckDB file, we guarantee that you will be able to read it with future DuckDB versions. Of course, we cannot do it all. So we have something called an extension mechanism. The extension mechanism means that you can define functions, you can define types, indexes, data formats, and SQL syntax into DuckDB. And we are heavily dogfooding this. So many of DuckDB's core functionalities are actually implemented as extensions. So HTTP support, Parquet, and JSON, they are all DuckDB extensions that we then bundle into DuckDB. And what our vision is to ultimately have something like an extension ecosystem where DuckDB stands in the middle, kind of weaving together the work of all these extensions. And the extensions doing the work of things like vector similarity search or supporting the AWS cloud, the Parquet format, or the Delta Lake format. And this summer we have opened up DuckDB. So we have a community extensions repository, which you can think of as DuckDB's package manager. So what do people use DuckDB for? I will be blunt and I will say mostly reducing costs. People just do local data processing instead of using a Spark cluster or using an expensive cloud data warehouse. They just perform things in-house. And DuckDB is free because it's an open source system, and it's also very efficient because it's a single node system. We ran a couple of experiments against Apache Spark and found that if you take the TPCH workload, which is a well-known database workload, you will have an 8x difference between Spark and DuckDB if you run them on the same amount of nodes. But if you keep increasing the number of Spark nodes, it actually never catches up with DuckDB, plainly because the overhead introduced by the distributed communication is just too high. So you end up in situations where you run 32 Spark instances, and it's still slower than a single node DuckDB on one of those instances. What's the business model of this? How do we make money of a database that we give away for free? Well, we run a small consultancy and support company in Amsterdam called DuckDB Labs. And here are a bunch of our clients. We are mainly funded by them and the revenue that they provide. So we don't take venture capital money. And this is important because in the last few years, it has been all too common for database systems to be open source and then suddenly be shut down into a closed source system. I think many people got burned by this, and people don't really trust open source databases that much anymore. And we fully understand this, so we took good care that this doesn't happen. In the hypothetical case that DuckDB gets sold tomorrow and the source code gets locked down by some big tech company, we still have something called the DuckDB Foundation. And the DuckDB Foundation owns the intellectual property of the project, and it receives donations from major contributors, including POSIT. And the DuckDB Foundation is something that guarantees the continued sustenance of the project. Now, DuckDB is this neat single node tool for working on your laptop. That's great. But what if you want a cloud data warehouse? Well, MotherDuck is the answer in this case. MotherDuck is a venture capital funded company. There is simply no way to build a cloud data warehouse otherwise. They are based in the US, and they build on DuckDB so that you get all the goodies of having a cloud database, storage, simplified database sharing, and even cool features like executing half your query on your laptop and the other half on a server in the cloud. So to sum up, DuckDB is this in-between system for datasets up to roughly 1 terabyte, and it really excels in that position. It supports full SQL, but it also integrates really well with dplyr, and it has a direct execution on top of duckplyr. Thank you, and if you would like to keep in touch, we are quite active on socials and very easy to reach.
Thank you so much, Gabor. I was telling you even before you joined the main stage, I've been a huge fan of DuckDB's efforts since the beginning as I started tracking the news that was shared, and part of our weekly project, we've had a few stories come in about DuckDB development. So thank you so much for sharing this. My quick question for you, I'll keep an eye on the chat for any, okay, well, there is a question from someone, yeah. So Nimisha is saying he or she is still a little confused. What makes DuckDB different from SQL?
Right, so SQL is the query language that relational systems use. So you can talk a pretty standard language, ANSI SQL, to Postgres, DuckDB, Oracle, and so on. And DuckDB is an implementation of that. And DuckDB is different from most SQL systems that one would find in the wild by its very strong focus on analytics. So if you run an airline ticketing system and you have a transaction every millisecond, then obviously DuckDB is not a good choice. Then you should use a transactional database system. But most of these data sets that people analyze are very, very static. And you can just compress it down and then work on that representation and just create newer and newer tables from that. So it's not really something where updates play a huge role.
Great. Thank you. Thank you so much. And yes, I've been learning a little bit. Most of the SQL skills that I have been translatable directly, but I do see a lot of nice enhancements to the language that DuckDB offers, especially with these newer types of data coming in. So I'm really intrigued by that.
Yeah, indeed. I didn't touch on the so-called friendly SQL extensions, but we try to reduce a bit of the friction with SQL and just have trailing commas, very lenient group by clause, and so on.
Excellent. And then one last one from me is that I've been ever since the announcement about the community extensions, I've been watching that pretty closely because I do see some opportunities to bring DuckDB a little closer to how we ingest data in our pharmaceutical space. So I guess from your recommendation, for those who want to get involved with learning the best ways of building an extension or learning what's out there, what kind of resources would you point people to get started with extensions?
So we have an extension template that allows you to do this. And we have a bunch of community extensions. The thing about extensions is that developing extensions is, I wouldn't say easy, but it's not that difficult because it's a C++ code base. So you can write your C++ code. What's really difficult though is building it for all these different platforms. So we try to take care of that. And we have a GitHub repository that's a template, so you can fork it and you have all the GitHub actions that we implemented. And GitHub is willing to build it for free. So it's actually a really streamlined process. And then you can contribute it with a single YAML file into the DuckDB community extensions repo.
Excellent, excellent. We do have one more that came in the chat, if you don't mind. Edison's asking, is DuckDB a distributed database?
So no, it's not. It's because of the in-process nature, it's really focusing on single node. And you can, of course, use mother duck, which is an interesting category because it will be a distributed system of exactly two nodes. One will be a small node that's a laptop, and one will be another potentially rather large node that's running in the cloud, maybe that has 128 cores and a terabyte of memory.
Yeah, I've been watching the space around, the use cases of mother duck for a little bit because I've been thinking about, in our sector here in Pharma, we use a framework called Shiny to build web applications. A lot of times, people like us and many others in the community have hooked a Shiny app as a front end to database operations, whether it's a hosted database like a Postgres or MySQL, MariaDB, and whatnot. Do you think Mother Duck in combination with DuckDB be a good fit for that, or even just DuckDB straight up might be an interesting use case there?
Well, both work, and this also ties neatly into what someone is asking in the chat about WASM use cases. So DuckDB has a really strong presence in WebAssembly because it can, due to its portability, it can run in the browser. So you can just have the entire DuckDB analytical system running on a smartphone in the browser. And what people use this for is then they build these super snappy dashboards where the data is loaded onto the client side, and then the last bit of slicing where you do some pivoting or aggregation or filtering, that can happen locally, and it gives this very instant feeling. And this works with both MotherDuck and DuckDB. So all the integrations apply.
I'm really intrigued by that possibility. I have an open source project that I'd love to get my hands on DuckDB with the combination of WASM and WebAssembly to see what kind of efforts we can make there. Oh, I do see you put in a link in the chat. I was mentioning to some of our colleagues that the DuckDB project has a Discord channel for getting in touch with other users and developers, right?
Yeah.
Excellent. Excellent.
Yes, exactly.
Yep. And then yeah, we'll keep this going if you don't mind, if you have another minute or so.
Sure.
Is there a solution or package for, say, the data coming from like a PDF form to come into a DuckDB database?
So I'm not aware of it. At that point, I would delegate it to some script that does this. It could be a Python script. It could be ChatGPT for that matter, and then just pipe it. We do have a text reader, so you can read text files quite flexibly, and you can also just hammer into a JSON or CSV format.
Excellent. Yeah, I could see like you stitch a little bit of pre-processing together, getting into like a format such as JSON or other machine readable, feed that into DuckDB, and you're off to the races. And also, I've had great success in my limited testing with Parquet files being ingested into DuckDB. That really, Parquet in itself could be another talk. It's almost like the new
Yeah.
CSV, if you will, in data science. That's been really reliable, I think.
Yeah, I when I analyzed the survey results, I found that more people use Parquet with DuckDB because it's kind of the natural thing to dump out of DuckDB once you're done with the analysis, because CSV will only introduce troubles further down the line. But Parquet is fairly standardized.
Yep, and speaking of that, stay tuned for our last day of our Pharma because there will be a feature talk on the Parquet format that a lot of us in the pharma space are paying a lot of attention to. So, well, Gabor, you can see a lot of people are really interested in
Yep.
learning about DuckDB. Are there any other additional places you'd point people to for those that want to get involved from like the R side or Python side with the
Yeah, so
DuckDB?
we have a fairly extensive blog, and we do deep dive blogs as well. There are 2 blog posts on duckplyr. There are blog posts on pandas integrations. So I would definitely recommend that. And if just sign up to one of our socials, you will see all the new stuff in time.